Let's do a few exercises in calculating probabilities for a normal distribution. Remember that the key to this process is the standardizing formula that allows us to move from the normal distribution to our population data to the standard normal distribution, where probabilities are presented on our standard normal table. To see just how easy it is to compute a probability for a normal distribution, consider the following example. Assume that the ages of people in a certain city are normally distributed, with a mean of 50 and a standard deviation of 20. What is the probability of randomly drawing a person from the phone book who is older than 100? This is a probability problem because we have all the information, the population mean, the population standard deviation, and the fact that the distribution is normally distributed. Now what we can do is draw our picture of x's. These are ages. It's a continuous random variable. We know it's normally distributed, and we're given the mean. And the mean is 50 years. The standard deviation, and I always kind of like to write it up here, is 20 years. Our question is, what is the probability of drawing somebody that's over 100 years? Mathematically, we're asking the probability that x is equal to or greater than 100. And that's this area here. Okay? Now, what we need to then do is to calculate on the standardizing formula our value on the standard normal table. This is a z-axis, please note that. This one here is the standard normal distribution. It has a mean equal to 0, and then we bring this down to here, and that's z1. So what we need to do is use our standardizing formula to calculate z1, and then look up z1. z1 is equal to, this is x1 here, is equal to x1 minus mu divided by sigma. Okay? We simply plug in our numbers here. And so z1 is equal to 100, the value we're interested in, minus the mean of the distribution, 50, divided by the standard deviation of the distribution, 20. And so we got 50 divided by 20, and that's equal to 2.5. Okay? So this is 2.5 standard deviations away from the mean. We can look that value up in the standard normal table, and what we find here is that the area is from here to here is 4938. But that's not the area we were after. We wanted to know the probability that someone's over 100 years. The way the table is structured, it goes from 0 to the z value, so we know this number. However, we also know that half the distribution is to the right. So if I take 1 and I subtract 4938, then I'm going to get the residual here. Sorry. If I subtract from 0.5, I'm going to get the residual. And so what we find is that that's equal to 0.006. So this area here is 0.006, and there is our answer right there. Now, anything that is 2.5 standard deviations away from the mean is a very unusual event. This will become a basis for much of what we do once we meet inferential statistics rather than probability theory, where we know everything, including the ages of every single person in the hypothetical city.